So, good afternoon, happy Saturday. Thought I'd create a little video to answer some of the questions that I've been getting from students regarding the lab project. So the first thing I'd like to discuss would be how to create a pie chart. So what you have here is basically your Excel spreadsheet, so you should be familiar with this at this point. So again, every time you open this up, let's save it as a different version, just in case we make a mistake. And right, so in the questions it asks you, make two pie charts for data sets 4, 6, and 7. So the reason we're using these data sets 4, 6, and 7 is because these sets, so again, feel free to comment on anything, right? Like, maybe I'll comment right here. These sets are good for pie charts because the raw data is categorical, or qualitative in nature, right? You'll notice that in the other, when we're making histograms and we're making frequency polygons, we had to categorize the data first, right? That's what you're doing when you're creating those classes and categories, is categorizing, right? Categorical, but this one's already in categories. Right, so let's look at what those data sets are. So let's just deal maybe with, let's do the vaccine one. Not just because it's the smallest, but just because it's the simplest. So let's deal with that one. So again, let's copy and paste this and move it to a new area so we don't screw up anything too badly. Okay, don't really know what happened there, but that's fine. So let's just get rid of that. Okay, so again, let's kind of space things out. Let's give ourselves lots of room. All right. So these are the categories, right? Your categories are already made for you. You don't have to worry about the classes already. So here, we have three essentially we have three categories, right? And these are the frequencies here, right? These are the frequencies of the voting. So maybe if anything, just to create it nicely, you can just kind of move this over and call this a frequency. So from here, what do we need to do? We need to figure out, so again, this would have been on one of the charts, or this would have been on the PowerPoint presentation on something called, you need to figure out what's called a relative frequency, right? Pie charts show percentages. So we need to figure out what the relative frequency is compared to the total. So maybe figure out the total here would be good, right? How many people actually voted? So we can take a summarize. We can take a sum. There we go. So 55 people voted. And so how do you figure out what percentage, right? So what's the relative frequency? Well, the relative frequency would be 31 out of 55. And if you want to make sure this doesn't move as you shift it down, you can use these special money symbols. That freezes that number, so when I drag it down, it's not going to change. So now we're almost ready to do a pie chart. Right now you can, again, pie charts usually show percentages, so you could go percentages, maybe show the symbol for your chart later on, and then, well, this number, that's going to be supposed to be this number times 100. And we don't need that many decimals, right? Maybe, again, you want to use an appropriate level of precision, right? You don't want too many decimals. All right, so that looks good. And now you can make your pie chart, right? So you could say, maybe, let's see what happens if I go like this. And then I hit Control, right? So you can highlight different areas. Let's go Insert. Let's go to Recommended Charts. Yeah, the pie chart looks good. Okay, so then just if you give it appropriate, you want to use give it a better title, right? So that it actually says what this is, and you can add. Let's add a data label maybe. That looks good. Then you can fool around with this. Your call. Okay. So hopefully that clarified some of those. Any questions on how to do it? Again, I don't really care what data set you use. You can do what I just did if you want, but I want you to make two of them, right? So you're going to have to pick something else, either the grade expectations, or you could do the satisfaction on people's computers. Yeah, and good luck. And please, again, make sure you comment on anything that you did, right? So I want to know. I want you to be able to talk about the graphs that you generated. That's a major skill set that we're trying to develop in our students. Is we find that students have a tough time explaining what they're doing, right? So we want you to be able to say, talk about these graphs or talk about the results in ways that are meaningful. And the second question I had from students over the last couple of days was, what about this crazy data sets where there's obviously values that are wrong, right? Or bills, this one's a weird one, and so is the mug diameter, because somebody made a mistake in both of these, right? Let's take a look at the phone bill one. If I look at the phone bill one, when you sort this, it looks really weird, right? There's some values that are just strange, like $5 a month. This is a little low, but the really weird ones are here, right? Like the 70 billion value. Let's just get rid of that. So there's something that I haven't quite talked about because it's not really until chapter 3 that we start discussing this, but there's something called trimming the data. So I might as well bring it up now because it's an issue. So trimmed data refers to the removal of the lower and top 10% of values. And this is the purpose of this is to eliminate extreme values without affecting the majority of the data. And so you're allowed to, you don't have to do if you're going to trim the data, just mention what did you trim, right? So let's say I want to get rid of the bottom 2 and I want to get rid of the top 2. So what percentage is that, right? So if I'm going to eliminate, so 10% to removal of the lower and top 10% of value. That's what you just call traditionally trimmed values, but I'm just going to trim the bottom 2 and the top 2. So what is that? So let's figure out what percentage that is. So 2 out of, so I got, how many was the total size? 49. So basically I'm going to do like a 4%, I'm going to do a 4% trim data set. So in this case, I'm going to trim the data 4%. Right, I'm going to trim 4% from the bottom and the top. You can't just do one or the other, or else it seems a little biased. So you usually have to do the same. So if I'm going to remove the bottom 2 and the top 2. So I guess I can just go like this. So again, the real weirdness is up here, right? So let's just get rid of that. $5.99 seems too high. $5 seems too low. Although I do believe that you can get that, right, in some countries, for cheap cell phone plans. But when you post that in there, now you get a nicer, much nicer range that you can deal with when you're creating your tables. So again, just mention that you did that, right? Maybe in your questions here, when you discuss, let's say you did a histogram, that was in question 8, that I mean over here, right? This 8 is this 8, not set number 8. But let's say you used it here, right? You say make 2 frequency polygons. So you say the data set for the phone bills was trimmed to exclude some obvious extreme values, and then just put the percentage, say 4%. Okay, that means bottom and top 4% were trimmed. So again, you can do up to 10% normally without it being weird. So if you want to trim even more, I'm cool with that. But again, just make sure it's consistent from the bottom and the top. All right, so have fun with it, and I wish you a wonderful weekend. Okay, take care, and I'll see you guys on Monday or Tuesday or Wednesday, whenever it is. Okay, bye-bye.